Hey everyone, and welcome to Logik Talks. My name is Blake Grubbs. I'm the head of marketing at Logik.io, and I'll be hosting Logik Talks to bring you interviews with experts in the quote to cash space, in sales, and in the digital commerce space as well, to hopefully share some of their expertise with you. Really excited to share all of this with you. Hope you enjoy. Awesome. So today I have Jeff Wilkins here from the Logik team. He's one of the co-founders of Logik. Really excited to have him on because he is our rules engine, solving engine expert here internally. He knows a bunch of stuff that no one else really knows about. So we're really excited to have him on this series here today. So Jeff, I'll pass it to you first. You want to just introduce yourself, what you do here at Logik, and kind of what your experience is in the space?
Sure. Thanks. I do know a ton of things that no one else knows. Co-founder, built out a lot of the core of the rules engine that we've developed for the product. And that's my role, is basically like shepherding all of the new development through that, doing enhancements, building that on, and trying to make it the best in class.
Awesome. And so have you worked with the Big Machines team and Chris and all of those folks in the past as well, right?
Yeah. I worked with them quite a lot. Richard was my boss. Chris was my boss of the boss of the boss. Knew them quite a while from the old Big Machines days, and that's how we all got intertwined and started this.
Awesome, great. Yep. And I'm a newcomer to the family here, so I always have trouble putting those pieces together sometimes. So that's question more for myself than anyone
You
else.
Never know it.
So let's start it out here. You know, like I said, I'm new-ish to the space and to configurators and CPQ in general. So the whole concept of a solving engine or rules engine was new to me to start. So for those folks who might not be familiar, like myself, could you go through just like, what is a solving engine? What is a rules engine? And kind of what role does that play here within a configurator like Logik?
Sure. So what is a rules engine and what is a solving engine? To answer that question, I'd break it down into thinking about the problem that we're trying to solve. So if you're running a company that's selling a complex configuration, in order to actually generate the thing that you want to sell, there are an awful lot of rules that you have to follow. So for example, if you're building a crane, you may have restrictions on the height of the crane can get based upon the dimensions of the base that you have. Or if you're building a dump truck, you're not going to be able to extend that dump truck's bucket capacity without increasing the support structure and the wheelbase, things like that. And you can think about those as conditional statements, really. So if base of crane is 10 feet, then height of crane cannot get beyond 40 feet, for example. Things like that. And you'll notice this if you're just purchasing consumer electronics or something. As you're navigating through that guided selling experience, the options that you have available to you later on get restricted based upon the options that you make. And all of those essentially are conditional statements. So if I'm running a company, one way that I could solve that problem is I could actually just have my development team build out those conditionals for me. And then anytime I have to update with a new product line or edit an existing product line, then I have to go back to that development team and have them rewrite it. Not ideal, right? It's a high cost to making those changes. So the idea of a rules engine comes out where you separate out those rules from the system that's running those rules. And those rules are really built out in a declarative way. And you can think about that in as just a series of conditionals. So if A, then B, if C, then D, if E, then F, and so on, right? And then every time that you have something that you want to build, you just feed that thing through these series of conditionals and let the conditionals operate on that. And maybe it works well. Oftentimes it does. That's a really naive approach. And I think that's, 20, 30 years ago, that's what people were doing. Solving engines is more or less a step above that, because you want to think about if I have a height of my crane above 40 feet, then I have to clear it with some sort of regulatory commission or something like that. And so if I'm starting to adjust the height based upon other conditions, I actually have like a feedback loop that can take option A, updates option B updates option C, and then you could even have it where option C goes back to option A, right? So now we have the solving engine concept where it says, okay, I have a series of conditionals. The conditionals will actually update the state of the thing that I'm operating on. And then that state can actually kick off further rules in here. So instead of us just having, here's a document with a bunch of conditionals, run your object through these conditionals, and then here's your output. It's give me a current state. I'm going to execute on that state until it comes to a coherent status, and then I return that status to you, right? So it's going to, when it settles on what that thing should be, then you get it back. And that's really what we're talking about when we're talking about a solving engine.
Got it. That makes a ton of sense. And so it's really an intelligent, more elegant way of running those rules. Like one thing that I was curious about when I started and we started talking about solving engines and rules engines and things like that was, do all CPQ applications, or even most CPQ applications or configurators in general, have this concept of a solving engine or rules engine involved? Can you talk a little bit about that?
Yeah, I'd say most CPQ solutions or configuration solutions, they're going to have something at least at the level of a rules engine, where you're able to separate out the rules from the actual logic that's going to be executing them. I know not every solution is going to have a solving engine, and to be fair, I think not every solution actually needs a solving engine. If you're selling crayons and there's not a whole lot of configuration and you don't have a whole lot of depth of rules and there isn't that feedback loop, yeah, why not? You can use some off-the-market rules engine that just stores conditionals. You run your thing through the conditionals and you're done. If you have a billing system that it has very simple logic and just a lot of throughput, you could do the same thing. So solving engines really come into play at the high end when you're dealing with the high complex use case. And that's where some vendors have gone into that direction. Some others don't. I would say, if you run into issues where you do need to have that complex use case and you're on a rules engine, you're going to probably start seeing a lot of compromises. Like, oh, my admin just got really hard because now I don't know what order that my rules need to run. So I need to give it some sort of guidance there because it doesn't have that guidance embedded into it.
Yeah. That makes sense. And you just mentioned some of the compromises that companies might have to make if they have that complexity in their business, but they don't have an adequate solving engine. Can you talk a little bit about what, in terms of performance and other aspects and the experience that's actually delivered to the end user using a configurator, what value does a solving engine actually bring to those folks, especially at these companies that have a certain degree of complexity to their configurations?
Yeah, sure. So there's basically two customers for us. There's the actual admin that's going to be building these things out. And then there's the person who uses the thing that the admin built, right? The end user. That could be your sales group, or that could be an e-commerce solution, just anybody who's going through your product, right? So if you are talking about anybody who's using your product, that end user, a lot of it's going to be dependent upon how well your admin does his job, right? So if he builds out a very efficient rules engine, even if it's not a solving engine, they could potentially get very good performance, right? A lot of it depends upon the space and the domain that you're working in. However, if you are just on a rules engine without a lot of intelligence behind it, the likelihood of that happening is probably not going to be great, right? To be honest. And then the persona for the admin, right? So if you're on a rules engine, you're going to have a pretty hard time if all you have at your disposal are conditionals. So if you have things like feedback loops that you have to iterate over a particular cycle of rules several times before you actually meet out to an actual physical value that you want to end up on, you really can't do that without having this type of intelligence structure. And I've worked in the industry. I've worked on rules engines that don't do that, right? And there's usually some sort of hack or compromise that you have to do to try to get that. And that's a really difficult thing for an admin. This is going to just make your maintenance of the system to be a whole lot worse than, a whole lot higher cost than what it would normally be. Everything's going to take longer. Your performance is probably not going to be great. You may have to reach out to some third-party systems to be doing the calculations for you and then feeding off of that. So really having that intelligence is going to save you. One, I think the big payoff is just the adminning of that. It's something that you don't have to think about. you can think about in terms of like these conditionals, and then the conditionals get wired up. And then to your end user performance, well, it's not necessary that you would have bad performance if you have kind of a dumb rules engine in the background. Like practically speaking, you're never going to be able to get to the scale or the performance that you can if you have like a very smart thing in the back that's making these choices for you.
Yeah, that's an interesting point, something I wanted to talk about next, because you mentioned, the e-commerce and self-service use case. There's a lot of businesses, even businesses with highly complex products, who want to be able to sell their products online, sell them on their site, and have end users and customers actually be able to go and configure products on their site. That's kind of the way the world is moving, to open up those self-service revenue streams. How important is it to have one of these solving engines, or have a system that has a solving engine for that e-commerce or self-serve use case, would you say?
Yeah, I think you're sort of implying. All right, so the question is like, how important is it to have like a robust solving engine in the background? And I think you're implying that this would be for a very complex use case, right? So I would think like, what are the risks and what are the costs that we're going to hit if we don't have something that can handle this use case, especially in e-commerce? I know people are hypersensitive to a bad experience. Like I go and I might just be horsing around and like looking at, I wonder how much a new laptop costs. And that could turn into a sale very easily. If I go up and I'm starting to configure a laptop and it's sluggish, like I'm closing the browser and I'm going to watch cat videos or something like that, right? Like I'm going to move on. And I think that's reasonable. We shouldn't expect consumers to deal with bad technology, especially when we have the capabilities to be able to deliver them something good. So like basically, I think performance is a big cost just for that sale, right? And then you're also going to start talking about, well, okay, you want to scale out to be able to support 10,000 people configuring on your site at the same time. So this would be beyond a mom and pop shop to a very substantial e-commerce site. Can your rules system do that? It's an open question on a lot of vendors out there, right? One thing that we've been doing with Logik, we've had e-commerce in mind from the ground up, right? So everything that we have built has been tuned to be as pared down as possible, so that we can really scale up that user count, and without sacrificing on performance and without making like the deployment just a nightmare.
Yeah. And, you mentioned that, our solving engine and our product was really built with certain use cases in mind. It was purpose built for this, right? What were kind of the lessons that you guys learned, when you were at Big Machines and when you have built configurators in the past? What are some of the lessons that you've learned that have kind of allowed you guys to on the development side of Logik, really kind of start from scratch and really develop this kind of next generation version of a configurator that we have today?
Yeah, that's a good question. And we certainly have gone through a lot in the past of running into issues with things that we shouldn't have done. So the lessons that we have learned from our past, one is, I'd say, we have stripped down what a configuration is to the barest possible components that it can be. And then this offers us a couple advantages. One is we can look at every component of that configuration in isolation. So if I'm focused on just trying to do a math calculation on a specific field, I shouldn't need to bring that entire configurable product into whatever service I'm running that's doing the calculation for me at this current time, right? So that allows us to be really targeted with our memory usage, and memory usage is going to translate directly into scale, and then scale is going to translate directly into performance there. So that's a big one. And I think if you're not on the development side of like a configuration company, you may not even like think about it. You say, well, okay, I'm configuring a laptop. Like the laptop is just going to have attributes, and the laptop is going to have messages and potentially a products list. But how you store those things, and how you store them in a way that can be looked up quickly, and how you store them in a way that can keep them small, that's super critical when you're talking about an e-commerce site with 100,000 like unique visitors per day or something like that, right? Because now once that scale ramps up, you using an extra kilobyte of space makes a huge issue. And also, if you store that in a way that's not readily accessible and you have to like iterate over things, all of a sudden your scalability just plummets, your performance plummets, and then you have a lot of problems that you have to solve. So out of the gate, like lessons learned, streamline the object, focus on just like the core components of that object, and don't ever bring anything into memory that you don't critically need. Yeah.
Makes a ton of sense. Awesome. Well, that's all the questions I had for you here, Jeff. I think this is a really good overview in terms of how solving engines impact configuration, how we've really, purpose built that here at Logik. So really appreciate you chatting with me and appreciate the time.
No problem. Have fun.